So this is what I broke today out of the lathe. I'm going to take tool steel and make a new one because I'm not going to recast it, but I want it strong, so time to make a new one. Well, I got the block machined up to the size that I need. I've still got to cut the radius and bore everything out, and then also trim down the side and make this radius to duplicate this part, bore the holes in it for the pin, and drill and tap for the set screw there. But I've at least got it up to size, how thick everything needs to be, so on to the rest of it. So here's what you'd want to do to lay this part out. Take some Dykem and get the surface of it all blued so you can take your part and line it all up, and then you can engrave where everything needs to be so you know where you need to machine everything. Alright, to figure out where the holes go, there's a couple indents. It's kind of hard to see, but what I done here was I laid the part out where I needed it, and I have transfer punches that are the right sizes, so I know that this one needs to go right here, and this one needs to go right here. So I transferred the center holes onto the part, so now I can drill both of those. Then I can use the mill and mill this side out and bore this to the right size, and then finish everything else up. So making this part for the mill here, what I'm doing right now is I'm machining this circle part all the way down to its 0.35 thou down from the top, so it's 35 thousandths, or over a quarter of an inch roughly. So what I'm going to do now is go for the next pass, set this camera up here, you guys can watch it do its thing. I've got the CNC set up for it, so it'll cut a circle. And here we go. So it's actually running itself. Alright, so here's the new part now that it's made, and it's tapped for the set screw. It's got the pinhole, everything's done. The center hole's bored to the same size as this one, so now it's time to see if it's going to work. Alright, so here's the broken part that we made the new one of. Alright, here's the new part to replace it. So here's the final look at it. Now it's all back together, it's working good. So, very happy. Alright, today we're going to tram this mill in, and to kind of explain what tramming in is, it's zeroing the machine to where it's in as accurate as it can be, so the head's not tipped any which way. So, in order to do that, to start with, this is kind of an old school method, and it's a good way to start with, and that's using a cylinder square. So you put your cylinder square down, and then you run your quill down and lock it. Then you run your cylinder square up next to it, and this machine should be trammed in. And if you see here, there's no light behind it. I'm going to get a flashlight to double check, but there shouldn't be a gap running down through here. If there's a gap at the bottom, then we obviously need to move it, or at the top. That means that the pitch this direction is like this. So we'll check it here, and we'll check it here, and then after we check it with the cylinder square, I've actually got a tram gauge that we'll put in there and check it that way. So let me get a flashlight and show you what I mean. Alright, as you can see, the flashlight's on, and if I run the flashlight through here, there's no light showing through. except for down here where the quill's a different size, where the nut is. So that tells me that the quill is, well, maybe it is off just a little bit, but we'll see when we put the tram gauge on. But we know it's super close. So, oh, there we go. Yeah, it's there. Okay, so that axis is good, or that direction is good. So now I will move our gauge around. Move you guys around so you can see this. And we have some light at the top, but not at the bottom. So that is telling me, you see here, we've got no light here at the bottom. Let's see if there we go. Virtually no light at the bottom, but quite a bit of light up here at the top. So that's telling me that it definitely needs trammed in that direction. So we'll go ahead and get it close to the cylinder square here, and then we'll use our tram gauge and make sure it's set. So in order to adjust it in the direction that we need to adjust it, first I'm going to take the handle off. You got to loosen these lock nuts up on both sides. And then use this adjustment nut in the back to adjust it whichever direction you need to go with it. And right there, right there should be the money spot. So I'll go ahead and snug that down. I'm not going to tighten it all the way down because we're going to check it all with the tram gauge. Alright, now we're going to set the tram gauge down on the bed, and you know what, I'm going to get a set of parallels. Alright, I've got a set of 1, 2, 3 blocks on either side. So now we're just going to run the quill down and then lock it off. We want to try to at least go one whole revolution, which we're there. So, lock it. Okay, so now it shows, we'll zero this one. So we're going to spin the gauge, 0. And pick this up, set it back down. I'll move it a little bit more. Alright, that one's zeroed. We're going to spin this. Pick it up, set it down. Alright, 0, 0. Now what we want to do is we want to spin the gauge around and check it again, because these might not be sitting in the exact same spot. So now in order to make sure, what we'll do is we'll spin the head all the way around and then check it again on the 2 blocks. So unlock the brake, pick these up, spin it around, and set them back down. And then we'll come around here. That side is showing about 1 thou to the negative. And that one is showing 1 thou to the positive. So if we put that as a half, and this is a half, that should actually be pretty much 0. So that splits the difference. Now we're going to see if we're the same when we flip it back around. If we're a half thou difference. If so, then that's where we want it, because the gauges aren't set the exact same in the block. And that's got us a half and a half. So we're golden that direction. So now we need to do the exact same thing on the other axis. So it'll be here and here. So what I'll do is I'll actually unlock the quill, Pick it up, lock it back down, put some 1, 2, 3 blocks like so. Let's get this thing to lock the brake right there. Then I need to run it about right there. Unlock the quill. Okay. Now, we're 0 on this one and about 1 thou negative on that one. So, pick them up, reset it. Okay, we're 0'd now. Now I need to spin it around the other way. Release the brake. Spin it around. Lock the brake back. Oh, okay. Now we're 1 thou over and about 1.5 thou under. And that's 1/100th of a thousandth of an inch too, over a 6-inch span. So technically, it's pretty much right on. We're going to spin that to cut the difference there. We're gonna go to roughly 1/2 right there. Now we should be in the same spot when we flip it back around, within 1/2 thou of 0 on this side. So, release my brake. Pick these up. Set them down. 1/2 thou. And that one's a 1/2 thou. So it's still, it's off a little bit. So, okay. We need to adjust just a touch. Honestly, it'd probably be good for what I'm doing, but I'll go ahead and make it as absolutely precise as possible. Right there is going to cut the difference. So, if I 0 them out, they should be off the same amount on the back side, which that is not going to be the case because that is off quite a bit since I tightened it up. So let's loosen this, and then we're going to adjust it. So, right there's got it. 1 thou, 1 thou. Okay. And that just tightened it up, made it 1/2. Kind of go evenly with these. It's definitely tedious getting these things trammed in, but it's not that bad. It's really not. You do it enough times, it's becomes second nature to you. But you do need to check these quite frequently because this is all moving parts, so things do get bumped and everything. So every so often, it's a good idea to check it. Which the nice thing is, the cylinder square, you can check it and tell if you're pretty close or not. Definitely need to check it every time you move your head. You definitely need to retram it in, but it does make good practice to check it every so often when making parts too. You want to make sure everything is as accurate as possible. Tolerances are as tight as possible. And that also depends on what you're making too. I want to keep my machine as tight as possible when I'm making parts, so. All right.